Okay, so the last type of titrimetry is redox titrimetry. So in redox titrimetry, you involve what's called the oxidation reduction reactions between the titrant and the analyte.
So the reaction that everyone dreads. Yeah, I know. There's a bunch of. I mean, this the topic of redox reactions and balancing redox reactions is something that unfortunately most students don't enjoy. So you just have to count electrons. This is actually it's quite similar to just balancing acid and base reactions, right? Your currency for acids and bases are protons. In this case, your currency is electrons.
That's correct. So, because there are some balancing redox equations that can get complicated. It wasn't my favorite in college for sure. But
we actually have a lecture video. Yeah, we have a lecture video on that, on how to balance redox reactions. So you guys should check that out.
Mm-hmm. Okay, good. But thankfully, I'm just talking about introduction to these techniques. I don't need to get in depth in this topic, but generally speaking, so in a redox reaction, you have just like what Dr. McQueen said, your currency is the electron. So in a chemical reaction, in a redox reaction, one substance loses the electron and the other gains that electron. So when you lose an electron, the process is called oxidation, and that means the substance was oxidized. And then the opposite is the electron gain, which is reduction. So that means the substance was reduced. So the substance that underwent oxidation is the reducing agent, and then the substance that went reduction is the oxidizing agent. So in this type of titration, you can still use some sort of indicator, but sometimes the titrant can serve as its own indicator, especially if the oxidized and the reduced forms are significantly different in color. So here's just a list of indicators that you could use for redox titration. And if you are taking analytical courses, these are the common redox titration that you will encounter. So it's called permanganometry, where you use the permanganates to measure the amount of analyte. So that's permanganate is your titrant. Examples of analytes are iron, manganese oxalate, nitrite, and hydrogen peroxide. And then, of course, you have iodometry and iodimetry. So with one with an O in the middle and the other with an I. The iodometry is the indirect titration of your analyte with excess iodide, and then you use a starch indicator to determine the endpoint at the end of the titration. And then iodometry is a direct titration of the analyte, which serves as the reducing agent, and it's titrated with a standard iodine solution. So, like other type of titrations, you have more advanced techniques for determining your analytes, your anions and cations, but there is still an acceptable method for the determination of total fluorine residual. And so this picture just tells you the color changes during the iodometric titration. So you form a brown solution which contains triiodide, and then you titrate it with sodium thiosulfate, which converts your triiodide to iodide ions. And then you add the starch, which forms a purple starch I3- complex, and then just a few drops of your titrant, which is sodium thiosulfate, will give you a colorless solution. So there are several equations for this type of redox that we will not be talking about, but again, thank you, Dr. Jeff, for your emphasis. Make sure your equations are balanced whenever you're calculating equations with this type of titration. And then another practical application of redox titrimetry is the analysis of ascorbic acid by iodinometry.